In this tutorial, I'm going to show you how to wirelessly control electronics using JavaScript. I'll be using the Particle Photon. It is a Wi-Fi enabled microprocessor that sits in the palm of your hand. It has digital and analog I/O as well as serial port and I2C interfaces. It is pin compatible with Arduinos and has a very similar programming interface, all for $19. I really like this device. We'll hook it up to a breadboard and give it power from our USB port. That's just for now. We'll untether it later. In order to enable JavaScript control of this device, we're going to use Johhny-Five, a powerful JavaScript abstraction for hardware. It's kind of like jQuery, but instead of abstracting the DOM, it abstracts electronics. In order to do this, we'll need to go through a few steps, and I'll go through them in greater detail later. Before anything, you have to install Node.js. You need to create an account for the device with Particle. You need to claim the device with Particle. You need to flash it with the Voodoo Spark firmware, and then control it with Johhny-Five. Before you do anything, you need to make sure you have Node.js installed. Just go to nodejs.org and download it and install it. This will give you Node and NPM command line tools. You'll also need to create an account with Particle. Go to build.particle.com and create an account. In order to claim your device, we'll need the Particle command line interface, npm install -g, Particle CLI. Once that's installed, you can log in with the Particle CLI by typing Particle login. Now let's claim the device. Make sure your Photon is plugged into the USB port and is blinking blue. If it is not, you can put it into setup mode by pressing and holding the setup button for 3 seconds until it is blinking blue. Now type Particle setup. It will ask you if you would like to use the device connected via USB. Yes. It then tries to find it via Wi-Fi. Yes, we'd like to set up this device. It will connect the laptop to the Wi-Fi on the chip. And here you can enter the Wi-Fi details and confirm it. Return to your normal internet connection and wait for the device to connect to the cloud and start breathing blue. It asks to give your Photon a name. I'm going to call mine PhotonBot. Now log in to build.particle.io. Just to make sure everything is working, select Code and choose Blink an LED. This very simple example shows how 2 pins connected to LEDs can be blinked on digital pin 0 and digital pin 7. We'll only concern ourselves with pin 7 for now, which has an LED built right into the board. If you're familiar with Arduino programming, this will feel very familiar. Press the flash button now. This sends the code to the device. The chip will blink magenta while it is loading, reboot, and then start running the program. If you look at the built-in LED on pin 7, you will notice it's blinking. Very cool. Now, we want to load a more complicated firmware. Voodoo Spark is a firmware that opens up a TCP socket on the Photon and allows remote control of the device over the local network. Select voodoospark.cpp and copy the contents. In the Particle Build tool, create a new app and paste the code there. Click the flash button to send the code to the device. Now the device is waiting to be controlled, and let's build an app. Create a folder for the code to live in and initialize it with npm. Now install 2 things: Johhny-Five, which by default works with an Arduino, and Particle I/O, which replaces the Arduino communication layer with a new I/O layer that knows how to talk to the Particle with Voodoo firmware we just loaded. Create a new file called bot.js. The easiest way to get started is by getting a sample code from the Particle I/O project. Find the example labeled Johhny-Five I/O plugin and copy and paste into your file. Notice how it is asking for a device ID and a token. We can get them from the Build tool. Go into your app settings and copy the access token. Then, select the device properties and copy the device ID into the script. This code creates a board abstraction for us to connect devices to. After the physical board is connected, we configure an LED component and tell it to blink. Now, when we run the app, we will see that the board is blinking, this time with JavaScript. The JavaScript is running on my computer and sending commands to the chip over the local network. Let's get a bit more complicated. Here is a simple robot chassis. It has two motors, a breadboard with a photon, and a 2-channel motor controller connected to the pins on the board. It is also connected to a battery supply so it can truly be wireless. Instead of an LED, I want to create a rate motor. It uses a PWM pin which controls the speed of the motor, as well as a direction pin which controls forward or reverse. This particular controller requires an inverted signal, so we'll declare that here. There are 2 motors on this bot, so copy the motor to match the pins of the second motor. Telling the bot to go forward is just a function that tells the motors to go forward together. For now, use a max power of 255, but that can also be controlled separately. Reverse is the same. The bot also needs a way to stop. Left and right pivoting for good measure. With these devices configured, and the control functions defined, we need a way to control it. I like to use the arrows on my keyboard, so I need to set up an event handler for keyboard presses. The standard in pipe needs to be set to get the keys and listen. Now, a simple key map. I'm just mapping the key names to functions that I want to call. The key map can be called from the event handler. Okay, let's try it. Pressing the arrow keys on my laptop controls the robot. There are all sorts of hardware that is supported with Johhny-Five. If you go to Johhny-Five.io, you'll see loads of examples. Well, there you have it, a wireless robot powered by JavaScript.